Okay, so today we're going to look at a combination of all of the derivative rules that we've used so far. So derivatives are going to get a little more complicated because you're going to have to use more than one rule at any given time. Just before we do that, we need to do a little bit of factoring review, because when we get a derivative that looks something like this, we're going to need to learn how to factor it. So just looking at this, hopefully you can see that there are two different pieces to this. So we want to do just some common factoring and see what's common to both. Okay, so let's start with just our monomial terms. We have a 4x and an 8x cubed, so obviously a 4x is common to that. Okay, and now if we look at, let's say, the next binomial, let's look at the 2x plus 1 to the cubed, 2x plus 1 squared, so obviously 2 of those binomials is common to both. And finally, let's look at the last piece. Sorry, that's a 2. And we have an x minus 1 squared over here. And we have an x minus 1 cubed over here. So obviously 2 of those we're going to pull out. And now when we work on what's left over, we'll just open up a big bracket and we'll look at the first term. Well, our 4x was taken out, so we simply have a 2x plus 1 left. Maybe put that in brackets too, just in case when there are negatives. The entire x minus 1 squared was taken out, so then we have a plus in the middle. And in the second half there, we need a 2x squared. And then, as you can see, we need another one of these, the x minus 1. And then you will always create something that you can sort of expand and simplify easily right in there. So let's just do that quickly. We'll keep our common factors out front. And then in that bracket, hopefully you can see that we are going to get a 2x cubed. We are going to have a minus 2x squared plus a 2x plus 1. So that would be considered in factored form. Now let's try another one. This one just looks a little bit different. We've got our fractional, our square root exponents, or our fractional exponents. So we just want to look at these ones because it's a little different. So when you look at these ones, I think the x term is obviously obvious, but when you look at these, the general rule is sort of you want to take out the lower one, the smaller one, or the smaller fraction that you see. Okay? Okay, so here then, we're going to take out an x. We're going to take out the lower one that we see. We get an x minus 4 to the negative a half. And when we open up our giant bracket, we obviously just have an 8 left over. This time we're going to subtract. The x has already been taken out. And then what we actually have left over here is we actually have x minus 4 left. And if you take a look here, if we were expanding this back over to here, we would keep the base, we would add the exponents, so we have negative a half plus 1, so plus 2 over 2 gives us our 1 over 2 that we have right here. Okay, so it actually works out nicely that then we simply have x minus 4 to the negative a half, and then when we simplify that bracket, we just get negative x plus 12, a nice factored form there. Now, we always want to take this and we want to rewrite it, so we want to rewrite that with a positive exponent. So this actually becomes a rational function where we have that on the top, and on the bottom we have root x minus 4. Okay, so we're going to use these skills when working on some of these combination derivatives. Okay, so here's our first one, the one that we're going to differentiate, and you might want to just rewrite it just to remind yourself that this first function right here, of course, looks like this, so you can see that we would need to use the chain rule when taking the derivative of it. Okay, so first I hope that you can see that this is a product rule, so product rule kind of is the overlying rule that we're going to use here. Here's our first function. Here's our second function. And as I said, when we're taking the derivative of this one, though, we are going to have to use the chain rule as well, hence the combination of derivatives. So using the product rule, we're going to differentiate the first function first. So we have 1/2 x squared plus 4 negative a half. Then we're going to go inside, which the derivative is 2x. Then don't forget, we're going to freeze the second function. And then we're going to add in the product rule. So we're going to keep the first function exactly the way it looks. And then we're going to take the derivative of the second function, which this one is just fairly straightforward, is just 6x. Okay, so now we're going to need to use our factoring skills and simplify this. But just before we do that, I encourage you to just clean up any pieces. Like you can see here that you have a 2 divided by 2, and I would even recommend moving the monomials to the front, just to help see exactly what we have. So our first term, we have x squared plus 4 to the negative a half, and then 3x squared minus 1. And then our second term, we have our 6x plus our x squared plus 4 to the 1/2. So now we're going to common factor between the two terms. You can see that both of them have an x, and then you can see that both of them will have an x squared plus 4 to the negative a half, like we just practiced. Open up your square bracket. What's left over? We have just our 3x squared minus 1, and then we're going to add our 6. Okay, if it's adding, you don't really need to worry about the brackets, but if you're subtracting, just watch out because you will need the brackets. And then we have an x squared plus 4. And then just this one square bracket right here, you will just need to simplify that. So we have x squared plus 4 to the negative a half. We'll move that down on the next line as well. And then we end up with 9x squared. And then we have a negative 1 plus 24, so plus 23. And just a little nice reorganization, we want to make sure that we have it looking like a rational. We have x, 9x squared plus 23 on the top. No need to expand there, keep it in factored form. And on the bottom we have the square root of x squared plus 4. Okay, let's try another one. Okay, so hopefully by looking at this one, you don't have any rewriting to do, but hopefully you can see that we have sort of a quotient of two functions. So here's our top, our g of x, here's our bottom, here's our h of x. We will talk about multiple ways to do this, but right now I hope you can see that it's a quotient law question. Okay, so let's set it up. Let's think about quotient law, and hopefully it also makes sense to you that within this quotient we are going to have some chain rules, right? Because both of these are kind of like a triangle squared or triangle cubed. Okay, so using our quotient rule, let's just quickly fill in the bottom. The bottom is the bottom function squared, so we have x squared plus 4. When we square that, we of course get to the 6th. Now right in this first spot right here, we're going to take the derivative of the top. So the derivative of the top, we're going to use the chain rule. Okay, we've got a triangle squared, so first we use our basic power rule. We bring down the 2, 2x plus 1 to the 1, if you like. Now we're going to go inside and take the derivative, which is just 2. Now, don't forget to just write the bottom function the way it looks. Okay, now we have a minus. Now we're going to freeze the top function exactly the way it looks, 2x plus 1 squared. And now we're going to look at the bottom function as its own little triangle cubed, and we're going to take the derivative of it. So we're going to bring down the 3. We have x squared plus 4 to the 2. And lastly, go inside, we have our 2x. Okay, so there's our using all of our basic derivative rules. Those are the key steps, and now we're going to work on simplifying. So just like we did with the last one, let's bring coefficients and monomials to the front of each piece and do a little bit of simplifying. And then we're going to use our common factoring, and we're going to always factor the top. Okay, so first we'll just clean it up. You can see our first term here, we're going to have a 4. We have our 2x plus 1, x squared plus 4 to the 3. Then you can see in the second one, when we combine the monomials, we have minus 6x. We have 2x plus 1 squared, and the x squared plus 4 also squared. Of course, don't lose the denominator. That's all over x squared plus 4 to the 6. Okay, so now we're ready to factor just on the top. Okay, so looking at the two separate pieces, we're going to pull out what's common. So you can see we can pull out a 2, first of all. We have a 2x plus 1 in both of them. And then we have an x squared plus 4, 2 of them common to both pieces. Now open up your square bracket. What's left over? We have a 2. We have an x squared plus 4 minus 3x. We have, and then a 2x plus 1. Okay, and again, just like before, we can simplify this piece right here until it's fully in factored form. Sorry, so we have our 2x plus 1, x squared plus 4 to the 2, and when we simplify that, we get negative 4x squared minus 3x plus 8. And don't forget your bottom. We have x squared plus 4 to the exponent 6. Now, the one interesting thing about when we do quotient rule, now that we've done this factoring, is you'll notice that we have 2 of the x squared plus 4's on the top, 6 on the bottom, so we can actually cancel those out and make that a 4. Okay, so there will usually almost always be that extra little simplifying that can be done as well. Okay, so on the top we end up with just this. Sorry, that's a 2 minus 3x plus 8 all over x squared plus 4 to the exponent 4. Okay, so be ready to try some of these tomorrow in class. They are going to take some practice. We'll be working on different combinations and work to be as complicated as we can be. See you tomorrow.